Hello, my name is Fazia binti Karim and my matrix number is BB221105113. So I'm going to explain about part 1, which is construct appropriate graph or chart to compare relative frequency and cumulative relative frequency between the two matrices. Comparison relative frequency between number of visit and number of purchase order. The first thing we need to do is we need to divide the number of visit and number of purchase order into classes and find the frequency. After that, we need to find the relative frequency. Formula for relative frequency is class frequency divided with total number of observation. For example, 3 divided with 30, we got 0.10. This table shows frequency for number of visit and number of purchase order. This is the bar graph that show the comparison relative frequency between number of visit and number of purchase order. As we can see here, relative frequency for number of visit is increased until classes 25 million up to 50 million and decreased until classes 50 million up to 75 million. Meanwhile, for relative frequency for number of purchase order is increased until classes 150 million up to 175 million, and after that it decreased until classes 225 million up to 250 million. Comparison cumulative relative frequency between number of visit and number of purchase order. This table shows cumulative relative frequency for number of visit and number of purchase order. To find cumulative relative frequency, we need to add from class to class from relative frequency. For example, cumulative relative frequency for number of visit is 0.10 plus 0.83, so we got 0.93. This is the OGIF graph that shows cumulative relative frequency comparison between number of visit and number of purchase order. As we can see here, for number of visit, the lowest one is on classes 25 million and it increased until class 75 million and maintain after that. For number of purchase order, the lowest one is on class 125 million and increased until classes 250 million.
My name is Guy Meng Sang, and I'm going to explain about part 2 where we calculate and compare the measures of central location between the two metrics. First, we're going to find for the number of visit, and first we're going to find the mean. For the mean, we're going to sum all of the data set, which we will get 1,131.4 million divided by the number of set, which is 30, and we will get 31.71 million. That is the mean for the number of visits. After that, we will get the median. We arrange the data sets according to ascending order, and then we will take the average number in the middle, which is number 15, number 16, which is 34.1 million plus 39.1 million divided by 2, and we will get the median, which is 34.5 million. And lastly is the mode, which is the frequency that appears the most in the number in the data set. The mode is 34.1 million, which is QOO10 and also Padini. Next, we're going to count for the number of purchase of order. And for the meme, it is pretty much the same. We to sum all of the number of purchase orders and divide by 30, which is 504.5 million divided by 30. And we get the mean, which is 166.82 million. And for the median, we'll arrange it with ascending order and then take the middle value, which is the 15, the 16 number, and we divide by 2 and we will get the median, which is 163.9 million. And for this number of set of data, there is no mode. Next, I'm going to explain about the differences between the mean, the median, and the mode. For the mean, you can see it is a lot higher for the number of purchase than the number of visits, and the differences was 129.11 million, whereas the median is also the same, with the number of purchase is a lot higher than the number of visits, where the differences was 129.4 million. And the mode, there's also a differences where there is mode for the number of visits, whereas the number of purchase there is no mode.
My name is Adriana Huda. I'll explain part 3, calculate percentiles and construct box plot for each matrix. Calculate the percentiles for the number of visits. First, arrange the data in ascending orders from smaller to largest. The second, locate the approximate positions of the percentile by calculating n plus 1 times with p divided by 100. The third one is where LP indicates the locations of the desired fifth percentiles and n is the sample size. For locator 25 is 30 plus 1 times 25 divided by 100, which equals 31 times 0.25, and that gives 7.75. This 7.75 tells us that 25th percentile is somewhere between 7 and 8 observations. That is between 31.8 and 32.0. So the 25th percentile is calculated as 31.8 plus 0.75 times the distance between 31.8 and 32.0. The 25th percentile is 31.95 million, meaning that 25% of the score is less than 31.95 million. For Q2 or 50 percentile, the locator is 31 times 0.5, which gives 15.50. That is 0.5 of the distance between 15 and 16 observations. So the 50 percentile is 34.1 plus 0.5 times the distance between 34.1 and 34.9, and that gives 34.50 million. For Q3 or 75 percentile, the locator is 31 times 0.75, which is 23.25. So the 75 percentile is the 23.25 value, here between 45.1 and 46.4. So the 75 percentile is calculated as 45.1 plus 7.25 times the distance between 45.1 and 46.4. 75 percentile is 45.43 million. An outlier is a single data point that goes far outside the average value of a group statistics. The outliers are the points lying beyond the upper boundary formula Q3 plus 1.5 times IQR and the lower boundary formula Q1 minus with 1.5 times IQR. These boundaries are referred to as outlier fences. Next, to find interquartile range, subtracting Q3 45.43 with Q1 31.95, that gives 13.48. So to look for an extremely low value, take Q1 31.95 and minus 1.5 times the IQR 13.48 equals 11.73. And to find an extremely high value, it must be larger than Q3, which is 45.43 plus 1.5 times the IQR 13.48 equals 65.65. Thus, any value smaller than 11.73 or larger than 65.65 is considered an outlier. Looking at all of the value, we can see that 23.0 million is larger than 11.73 and 54.2 million is smaller than 65.65 million. So, there are definitely no outliers for both lower and upper limits. For calculating the percentile for the number of purchase orders, using the same formula as calculating the percentile for the number of visits. For L25 is 7.75. The Q1 is 140 million. For 50 percentile, the locator is 15.50. So the Q2 is 163.90 million. For 75 percentile, the locator is 23.25. So Q3 is 197.55 million. Next, the IQR for the number of purchase orders is 57.55. The lower limit is 53.67 and the upper limit is 283.88. Looking at all of the value, we can see that 182.80 million is larger than 53.67 million and 231.90 million is smaller than 283.88 million. So there are definitely no outliers for both lower and upper limits.
My name is Shirley Ainziman with matrix number BB2211037. I will explain for part 4 where the question required to calculate and compare the measure of dispersion between two metrics. The table on the left shows dataset for number of visit and number of purchase order. Meanwhile, the table on the right shows the methodology used in calculation. The first one is range, where maximum value minus with minimum value. The range for number of visit is 31.20 million. Meanwhile, the range for number of purchase order is 115.40 million. The range for number of purchase order dataset is higher than the range for number of visit dataset. This indicates that the number of purchase orders are more spread out than the number of visits. Next is the mean absolute deviation, where the formula for sample met is the total sum of the distance between the dataset and its mean divided by the sample size. The met for number of visits is 7.45 million and the met for number of purchase order is 25.66 million. The met for number of purchase order is higher than the met for number of visit. This shows that on average, the number of purchase order for each e-commerce website deviate more from the mean than the number of visit for each dataset of e-commerce website. For variance, the total sum of squared distance between the dataset and the mean divided by sample size minus by 1, which is 29. Therefore, the variance for number of visits is 76.10 million, while the variance for number of purchase orders is 987.59 million. The variance for number of purchase order is higher than the variance for number of visit. Again, this means that the individual data is more spread out from its mean, which can be caused by a large difference between individual data points. Standard deviation is the square root of variance. Therefore, the standard deviation for number of visits is 8.72 million. Meanwhile, the standard deviation for number of purchase order is 51.43 million. Last but not least, the coefficient of variation, where the standard deviation divided with mean. The coefficient of variation for number of visits is 0.23 million. Meanwhile, the coefficient of variation for number of purchase order is 0.19 million. The standard deviation for number of purchase order is also higher than the standard deviation for number of visits, as the variance for number of purchase order is higher than the variance for number of visit. However, the coefficient of variation for number of visit is higher than the coefficient of variation for number of purchase order. This shows that the standard deviation for number of visit is relatively higher compared to its mean than the standard deviation for number of purchase order to its own mean.
Assalamualaikum and hi everyone. My name is Nurul Najila bint Irwan. My metric number is BB2211073 and I'm going to explain for the part 5, which is calculate and interpret measures of association between two metrics. Covariance indicates the direction of the linear relationship between variables, while correlation coefficients measures both the strength and direction of the linear relationship between two variables. And here is the formula for both covariance and also correlation coefficients. For an example, for the data one, you just have to multiply the 53.8 with the mean one, which is 37.31, and you will get 16.49. Same goes to the y for data, which is 199.4, multiplied by 166.82, and you'll get 32.58. And you just have to multiply both of them, and you'll get the answer 337 and 24, and as the following rest. And here is the final answer for covariance, which is 176.91 million. For correction coefficients, we just have to divide it by the standard of deviation for x and y, which is you're gonna get the answer 0.65. The number of visits and the number of purchase orders have a 0.65 association coefficients. This shows that the two indicators have a significant positive association with one another. Put differently, online retailers who have a higher volume of visits also typically see a higher volume of purchase order.